Hi, so I've got a optical computer drive ripped apart here. This was a DVD burner, and I just wanted to take a look at some of the electromechanical systems inside of it. And I find it interesting. We've got four different mechanisms here for movement, and each one is different. So we'll start with the tray opening and closing, and that's just done with this basic DC motor here. It's all geared together to open the tray, and also it's responsible for engaging the spindle here. It actually drops, this whole mechanism drops down so the tray can open, and then when the tray closes, this pushes back up. And it's a clever little bit there. They've got an interlock, so that's why the tray actually doesn't open. If you try to pry the tray open on a drive before, you need to put a paper clip in to release it, and then it just pops right open. But if you try and give a little tug, forget it, it won't go anywhere. And that's why, is because this is actually pushed up and in there. So, no surprise that there's just a regular DC motor to drive that. There's no real accuracy required. It's easy to just use limit switches. Speed, doesn't matter too much, like the consistency of the speed. It can speed up, slow down under load, and it's not going to make a bit of difference because all you care about is fully open and fully closed, and you can detect that with limit switches and turn your motor on and off accordingly. So once the disc is loaded in and this mechanism is popped up and you've got the disc sitting here on the spindle, now you got to spin it around. And you can use just a DC motor for that, I suppose. Like, here's one here that I recently bought. This was a replacement motor for a standalone DVD player, and that's all it is. It's just a regular brushed motor. I bought this for a specific project that I just haven't gotten around to yet. But that's not what this is. This is actually not a DC motor. Well, I mean, it is. It operates off DC, but it's not a straightforward motor. Now you see we got this big huge, well, for it being a motor, we've got this big huge flat flex here coming over onto this little board. And we take a little look, and we'll see that two traces come up to this switch here. This is a limit switch. But yeah, like, that's it. Two of these traces. The rest are for this motor. And so why wouldn't you use a DC motor? I mean, that's what I said they use in like standalone DVD players, and I've pulled apart really old computer CD-ROMs. Regular DC motors, you could just desolder them and use them. In fact, have used them before. They're exactly the same as this little guy here. They would use the same motor, which makes sense because you want to keep your bill of materials down. If you can reuse the same motor twice in your design, then that's great, because now you buy twice as many of these, so you should be able to get even a better price on them. Now, once you get up into these more complex units and you get into the higher speeds, you can't read the entire disc at the same speed, and a simple DC motor is great to get up to a certain speed. You've got that inertia, and away you go. Now, couldn't you just use a DC motor and simply vary the speed? Yeah, sure, you could. The problem is, you got to remember, that's a fairly small motor. You've got a disc that, although it's not heavy, the disc does have a lot of weight considering the speed that it's being spun at. Like, that's a lot of momentum there. You can't just instantaneously change that speed. We need to be able to detect the speed, and if we look at these traces, actually that probably will show up. We'll look at that first. There, so you can see we've got all these little traces, and they are little pissy ant traces. And then we've got three large traces. So these ones are obviously meant to carry a higher current, and in fact these are the three traces to bring power to the motor. These other traces here, see if we can see in there or not. Alright, you can, well, it's a little hard to see the last one, but there's one there, and there's another guy right in down, see, right beside my pointer. Oh, there we go. One more right there. And those are little 4-pin. They're a 4-pin package, and what those are is Hall sensors. So they're a magnetic sensor to sense as this thing's spinning. There's certain spaced a certain distance apart, so you can tell the speed and you can get really accurate readings. So that's what all these little traces go for. So that's fine. But why is there 3 power traces then? What is it? Positive, negative, and what? Well, not exactly. It's basically a 3-phase motor, hence why there's the three traces running in there. These are actually called a brushless DC motor, but I mean a brushless DC motor essentially is a 3-phase motor. You know, they operate in pretty much the same manner. Basically 3-phase motor in, I believe, a delta configuration. So these are used a lot with hobby RC, with larger RC cars and planes. So they provide a nice amount of power. You get a lot of power out of them, you know, high torque, and you can also get nice speed control out of them. So now we're up to 2 types of motors. Now next we've got a little carriage here with the laser assembly on it. And this moves back and forth. As you can see, they've got, you know, this fairly coarse lead screw here coming off another motor. And this motor here, we've got little flex with 4 different pins on it. So that's a bipolar stepper motor there. So you can position that within, I don't know how many degrees per step this is, but you can position your head now in different places. And you know, it's going to be like a notable amount that it moves at any given time. Now you could try and use a much finer screw on this and a finer thread system, and to get, you know, better positioning accuracy and be able to make that, you know, be able to move that in smaller and smaller steps. Now I haven't looked at you know, CD or DVD specifications. I don't actually know what the track width is, or like the spacing between tracks. There would be extremely difficult, probably impossible to get that kind of positional accuracy using this kind of a system. Now, even if you did have a finer system, because you see there's only the drive on the one side, now you'll see this here is nice and solid up here, not actually moving, but there's quite a bit of play there. Like, that's really sloppy. Now you could eliminate that by using a double drive system and driving 2 motors synchronously, or having 1 motor and have a gear system going across, although that's really difficult to do and not have any backlash in your gears. But instead they've opted for this, and the idea is that you position this here close to where you want to be. Not exactly, but close to where it is. And this brings us to the 4th mechanical system in here. This head looks like it's all a nice fixed assembly, but there's sort of, you know, some plastic missing in here, some cutouts between this. If you're watching in HD, you might be able to just see right about there at the end of the pointer. There's a little line running this way, and there will be right about, oh, there, if I get underneath it you can see. But anyways, there's multiple wires running across, and it's sort of suspended with these wires there. And as you can see, I've already touched it and it moves. So this here uses like a I believe it's called a voice coil mechanism. Basically it works a lot like a speaker does, except instead of getting this laser to bounce up and down like that, you want to get this lens and assembly to move like that. So you get it positioned roughly where you want it, then you can push your laser over, you know, and start reading, and then this thing here will just move across. There's a little coil under there to move it, just like how the heads in a hard drive are moved by a coil as well. Obviously once you get across, you know, this whole thing will move down just a hair. Now you move that back over there and you can keep reading from where you were and come across. Alright, so that's it. There's 3 main motions: loading mechanism, spinning the disc, and your read head, and they're moved by 4 different electromechanical devices. Alright, so that's it for this video. Until next time.